ready to go. All right. Ooh, didn't get set up for the right slide. We just finished last time upper and lower bounds rules, and we're getting ready to start application or example 10, but we didn't get there because of time. Nakia is here. And I can't see, but Jared's here. All right, good deal. So we'll be beginning there in just a bit. Let's get the slideshow set up for current slide. All right, one more, not major announcement, well, I guess it might be. It's sort of a bad news situation. Unfortunately, next week is Thanksgiving. And y'all get the whole week off. We don't, but you do. Bad news, okay? We've got professional meetings Monday, Tuesday, and a duty day on Wednesday. The college will be open Monday, Tuesday, and Wednesday. All the appropriate offices will be open and conducting business. So if you have business to do with the college, you can come and get it done. If you need to see an instructor or administrator, you might want to check first because, like I said, the professional meetings, unfortunately, these meetings are in Montgomery this year. So a lot of folks will be out of town. Okay, they'll be down in Montgomery Monday and Tuesday. They may be back here on campus on Wednesday, or they may take the day off. I don't know. But if you have business to do with the college, try to get it done Monday, Tuesday. If you have to wait till Wednesday, I would say get it done Wednesday morning because people get pretty scarce around here on Wednesday afternoon before Thanksgiving. In fact, usually some administrator will let folks go sometime in the afternoon. It could be as early as noon. It could be 2 o'clock. It could be 4 o'clock. Depends on how generous they're feeling or if they're back from the meetings or whatever. So I would say if you have business to do with the college, get it done Monday, Tuesday, or Wednesday morning. Don't wait till Wednesday afternoon. You might not find the person you need to see available. So try to get it done then. Any questions before we get started on today? All right, we're in section 2.5, chapter 2, polynomials and rational functions. This is the last section on polynomials, zeros of polynomial functions. And we're on example 10 at the bottom or near the middle of page 162. No questions? Okay. Find all the real zeros of alpha. Oh, let me get my pen color right. Okay. Alpha of x is equal to 6x cubed minus 4x squared plus 3x minus 2. Okay? Find all the real zeros of that function. Now, we have a bunch of tools in our belt. Okay? And this is lots of places where you could begin. Where would you begin? Any of you? Got to begin somewhere. Where would you begin? Got lots of possibilities here. Where would you begin? Say again? Set it equal to 0. Okay, and then what you going to do with it? It's an interesting start. What are you going to do with it once you set it equals 0? Because they're saying find all the real zeros. That's how you get them. Set it equal to 0. Very good. Where do you go from there? Okay. Good start, but where do we go from there? Diana's here. Okay. Any ideas? Come on now. This could show up on the test. Got to do something. What would you do? bunch of tools in your tool belt. Use some of them. How would you factor it? Any ideas? Not a bad idea. It's the first thing I would think to look at. How would you factor it, though? Or if not factoring, what else might you try? I'm not saying factoring's bad, but you know, if we're stuck there, try something. We got a lot of tests. Got a lot of. We're not talking about that kind of. A lot of possibilities. What would you choose to do? Second? Synthetic division. Okay, where would you begin there?
You're asking a lot of questions.
What's that?
You're asking a lot of questions.
Yes, I know. That's my job. Your job is to provide me with the right answers. Someone's doing this job, right? And somebody, no, I won't say that. Okay. It's a good idea to use synthetic division, but you got to have somewhere to start. Where do you find places to start? Okay, got that part. Okay, we'll get started that way. Okay, and what do I put where? 6, -4, 3, -2. Do we have enough numbers there? Yes, 4 numbers. The maximum exponent is 3. That's what we want. But I need to know what to go in the box. Any ideas? Okay. 1 will always work, but you know, you could check 1 easier than that. Remember, if you just plugged in a 1, that's saying x equal 1, you think might be a solution, a 0. Okay? Well, you can just plug it in. That would be 6 minus 4 is 2 minus 2 is 0 plus 3, not 0. So I know 1 won't work. So I don't even want to mess with plugging it in. Second? Okay, -1 certainly will work. Let me suggest to you something a little bit better than scatter shooting it, okay? What did we talk about before? Rational zeros test. That gives you all the possible rational zeros. The reason I let you say 1 and -1, they're always options, okay? But what does the rational zeros test tell you? The rational zeros of this function will be of the form P over Q, where P is what? No, P, little p. All the possible factors of the constant term. And what are they? Plus or minus 1 and plus or minus 2. That's why I let you get away with plus or minus 1. That's always an option. Okay? Plus minus 2 only because that is 2. Okay? And then what's the Q? All the possible factors of the leading coefficient. And what would they be? Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Very good. All right, now what we do is we list all those possible zeros. I like to take the ones over 1 first because those are the whole numbers, and that's where we get our plus or minus 1, and then we'll also have plus or minus 2. Then we do them over the fractional forms. Like this one, what would that be? Plus or minus 1/2. But this one would give us what? Plus or minus 1. We already have that. You don't need to list it twice. So we go to the next one, and that would be plus or minus 1/3, and this one, plus or minus 2/3, okay? And then we go to the last possibility, that's plus or minus 1/6, and plus or minus 2/6, but 2/6 is 1/3. You don't need to do that, okay? Those are all your possible rational zeros. Plus 1 was 1. It doesn't work, we know. Minus 1 is also a possibility. How do you do the synthetic division there? Skip a line, draw a line. I love it. Next. Bring down the 6. Negative 6. Negative 10. Positive 10. Second. 13. Negative 13. Negative 15. Is that a 0? No. Negative 15 is not 0. The only way this would be a 0 is if that were a 0. It isn't. So negative 1 won't work. However, do we need to try negative 2? It's a possibility, right? So we should try it. Why not? Looking here. If the lower bound test rules, if f of x is a polynomial function with real coefficients, yes it is, and a positive leading coefficient, yes it has. Suppose f is divided by x minus c using synthetic division. If c is less than 0, yes it is, right? And the numbers in the last row alternately positive and negative. Yes, they are. 0 entries count as positive or negative. Then c is a lower bound, negative 1 is a lower bound for the real zeros of f. Don't try negative 2. That's what the lower bound test tells us. So we're not going to try negative 2. Now, those fractional forms are less than negative 1, so we could try those. Do you want to try those? I'd rather try plus 2 first, okay? Because easier a little bit to do with that, okay? That's our lower bounds test. We could have saved ourselves some effort, though, had we used another test. And what's that? That board there. What's it called? Huh? Graph board, but we also have a name for it. The what? Some coordinate system. Okay? Say again? How about the word Cartesian? Okay, and where did that word come from? A guy. What guy? It begins with a D, Descartes. Does that ring a bell? How about with the current test at hand? Boy, last week was a long time ago, wasn't it? That Veterans Day holiday just sure took it out of us, didn't it? Descartes' rule of signs. Remember that? What does this tell us? Just looking at that polynomial there, what do? Count the number of sign changes. Is that 1? Plus to minus? Yes, it is. Is that 1? Yes, that's 2. How about there? Yes. What does this tell you? You have 3 or 1 positive. Always try to do that. Positive 0. Oops, hit the wrong thing. Sorry. Positive zeros. And what's the second part of Descartes' rule of signs? You write down f of. That's positive. Hint, hint. Negative x. Long time ago last Thursday, wasn't it? Okay. What is f of negative x? It'd be negative 6x cubed. How did you know to change that to a negative sign? Because your exponent is odd. Negative x cubed would be negative x times negative x is positive x squared times another negative x would be negative x cubed. That's why. Next. I minus 4x squared. Why did it stay the same? Because that exponent is even, right? A negative x times a negative x is a positive x, so that doesn't change that. You had a negative 4 there already, that became a positive x squared. So we don't change that one. How about the next one? Second? Negative 3x, yes, because that's an odd exponent. And negative 2. Then what do you do? Same as you did down here. Count the number of sign changes. How many do you have? 0. That means you have 0 negative zeros, okay, for that polynomial. What does that tell you? We wasted our time doing negative 1 because there weren't any negative zeros, okay? So hang it up. We wasted time, okay? So what we are going to do, not only do we eliminate, if we had done the Descartes rule of signs first, we would have known that none of these negatives will work. So you could go in there and take them all out if you wanted to. Okay? Because the rational zeros test only give the possibilities. Descartes' rule of signs would tell you whether, it gives you more information. So negative 1 was a waste of time. Okay? Sorry about that. And the zero, the lower bound test showed us that, negative 2 would have been, but if we'd have done Descartes' rule of signs first, saved ourselves a lot of effort. So we knew 1 didn't work. What you want to try next? 2, why not? So what does that give us? 8, 4, 8, 11, ain't going to work, is it? Okay? So that one's not going to work either. So 1's out, 2's out. Okay? Looks like we got to go with some of those fractions. Okay? Yay! Okay. We're happy. All right. Let's make it a 1/2, since I already got a 2 there. What would be next? 3, negative 1, negative 1/2. What would that be then? Okay, 5/2. It would be 2.5, which is 5/2. And then the next one would be no good. Okay, going to be 4ths, not going to work, not going to get a 0. So 1/2 didn't work either. Let's erase that one. Well, I could have left something there. Okay, what's next? Okay, 1/3. Let's try 1/3. What does that give us? 2, negative 2, next, help me. Negative 2/3. Great. Okay. What's next? Wouldn't it be 2 1/3? 3 minus 2/3 is 2 1/3, right? Okay. And 2 1/3 would be what? 2 1/3. That'd be 7/3, right? So that'd be 7/3. You think that's going to work? No way. That's going to give you 9ths. So 1/3 doesn't work. Boo hiss. Okay. What's next? 2/3. I'm beginning to get discouraged, aren't you? So huh? We'll get there. Okay. 1/3 I? Excuse me. Y'all awake yet? Okay. What would 2/3 give you? Two-thirds of 6. 4. Excellent. What would that give you? 0. What would that give you? 0. And 2/3 of 3. Oh, wait, I'm sorry. Add the 3, sorry. 2/3 of 3 is? 2. Guess what? Ding, 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 ding. We have a winner. Okay? 2/3 is a 0. So we found one of the zeros anyway. How many zeros might we have? Second? Okay. 3, up to 3. Okay? And we found our 1. We knew we had to have one positive real 0. We found 1. You could have 2 more, but you see, we're now at the point of a quadratic. So at this point, what would we do? Rewrite that as 6. What does that stand for? 6x squared plus 3 equals 0. Guess what, team? What would you do next? Factor? What could you factor? All I can see is a 3. 3 times 2x squared plus 1 equals 0. Well, obviously 3 is not equal to 0, so you could divide that away. So what if you had 2x squared plus 1 equals 0? What can you tell me about that? No real solutions. Because any number you put in there, any real number you put in there for x, you square it, it's going to be positive. Multiply 2 by it, it's still positive. Add 1 to it, it's still positive. It gets more and more positive. Even if you put 0 in there, it's going to be 1. 1's not equal to 0. No positive number is equal to 0. There's no more real solutions. We found the one and only one real solution. That was x equal 2/3, and the rest are complex, having imaginary parts to them. Now, I told you we don't have to mess with that. The book does find what it is. You can solve that for x, and that would be 2x squared equal -1, divide by 2, and you have x squared equal -1/2, and then you can take a square root of both sides, and you basically have x equal plus or minus I, because the square root of -1 is I over root 2. And you know, those are complex, imaginary parts. I'm not really interested. Okay, I just say one real solution, the others are complex. Okay? 1/6 wouldn't work for us. Okay? It was worth a shot, but since we hit 2/3 next, I said let's try it. Okay. So you see, use all the tools. Descartes' rule of signs. Well, first I'd do the rational zeros test. Then Descartes' rule of signs. You can do Descartes' rule of signs first, it doesn't matter. Actually, it might be better, because if we'd have seen on this one, no negatives, then we wouldn't have messed with any negatives. We'd have done 1 and 2, and 1 and 2, and 3 and 6, and just gone straight from there. So Descartes' rule of signs, rational zeros test, synthetic division, good choice, okay, just out of order, okay, and then when you get down to a quadratic, stop, see if you can factor it, see if you can use the quadratic formula, see what you can do. You're going to wind up with 2 complex roots on this one, okay? If you look at the book, you'll see they got x equal 2/3 is a 0, and then it's the only real zeros. Oh, the problem said find all the real zeros. Sorry about that. I didn't even need to mess with that. The problem said find all real zeros. We found it. X equal 2/3. Okay. And we showed that the others weren't real. There is a checkpoint there, folks. Look a little rusty, so I would say do the checkpoint. All right. Any questions on that? Do you see how to do it? Procedure. Take advantage of them. We've hit them all. Use them. Okay. If no more questions, we'll move to applications. Example 11 is you are designing candle making kits. Each kit contains 25 cubic inches of candle wax, that's a volume, and a mold for making a pyramid-shaped candle, okay? You want the height of each candle to be 2 inches less than the length of each side of the candle's square base. What should the dimensions of your candle mold be? You want to make one candle. They didn't say that, but I think that's what's implied here. All right. Now, you have a total volume or capacity of candle wax 25 cubic inches. Okay? You want the height of the candle. You know, I think what we have to do first, what would you do first? It's a great idea, even if you, draw a picture, absolutely. So let's read this a little more carefully. You want the height of the candle to be 2 inches less than the length of each side of the candle's square base. That gives you what you need to know. Your base here is a square. I don't draw very well, so forgive me, okay? Now, it's a pyramidal candle, so somewhere up here is the height of the candle, okay? Right there. I probably drew it too tall. And you have lines coming this way, and that way, and this way. There's your pyramidal candle, okay? It's a square base, so all 4 dimensions of the base are the same. And the height here, which I'm going to draw with a dotted line here, is 2 inches less than the length of each side. So obviously I don't have it quite right because, well, doesn't matter. Okay, so this statement here, let me label this. This is H, okay, for height. What do you want to name the side of the square base? Give it a variable, because it says, okay, I should have pointed this out. What should the dimensions of your candle be? Okay, I've got the height, that's one dimension. What's the other dimensions? The sides of that square base. What do you want to call that? Second? S. Okay, let this be S. Okay? Okay? So let H be the height of the candle. And S equal the length of each side of this candle square base. Okay. Now, this sentence right here, you want the height of the candle, what's that? H, to be, that sort of sounds like the verb is, so that's going to be equal, 2 inches less than the length of each side of this candle square base. What's S minus 2, you got it. There's a sentence for it. So that reduces 2 variables to 1 variable. So now the H is S minus 2 is the height of the candle. Okay. Now, What's one other piece of information we need?
25 cubic inches.
Okay, we got that. But what information do we need to use it? What in the world is the volume of a pyramidal candle? Now, if you don't know that right off the top, where could you go? Front of the book. Okay, good choice. If it's not there, it might be in the back of the book. But it's not on the front inside, not there, so it doesn't look good in the front. So let's go to the back of the book. Oh my, look at that, formulas from geometry. What are we talking about here? Oh my goodness, they don't have it, do they? Shame on them. Okay? But I'll tell you, it's a lot like your cone. See what the cone is? Second? Yeah. And that is a really strange looking cone too, isn't it, by the way? Okay. But anyway, it's 1/3 the volume of the sphere. What's that? Yeah, I know it is, but I was trying to get you to look. Okay. To look it up, yeah. But it's 1/3 the volume of the thing that, if it wasn't a pyramid, this would be a block, wouldn't it? And that block would have an area of S squared. That was the area times the height, which is this. So we know that the block would be, the volume of the block would be S squared times S minus 2. Well, the volume of the pyramid would be 1/3. I think I'll write it differently. 1/3 S squared times S minus 2. See, that's what it is. 1/3 the area of the base times the height. Okay? And the volume of the pyramid needs to be, to use all the wax, needs to be 25 cubic inches. So here's your equation. 1/3, and let's go on and multiply that out. Distribute. And what do you get? That's an S. It looks sort of like a 3, but it's an S. 1/3 S squared times S. S cubed. Wait, let's not even do that. Okay. Let's leave it just like it was. 1/3 S squared times S minus 2. There's a reason. Method for my madness here. Oh no, we do need to do it. Sorry. I thought it would help, but it won't. So let's go on and distribute. Okay. That would be S cubed minus 2S squared is equal to 25. Right? All right. Now what do we do? What's messy with that equation? The fraction. And how do we get rid of it? Multiply both sides of the equation by 3. So that gives us, I'll write it up here, S cubed minus 2S squared is equal to 75. Okay, is that the form we want to use it? Why not? Because this is a power greater than 1. 2 and greater, you want to get everything on the left and the right-hand side equal to 0. So this will be S cubed minus 2S squared minus 75 equal 0. Now we start looking for our zeros. Okay? And what might you do first to find the zeros for that equation? Okay, it was a long time ago we worked the last problem. Well, there's some of the tools we do. Say again? I can't hear you. Okay, we're going to use Descartes' rule of signs. And how many sign changes do we have with that? 1. So that means we have one positive real root. Okay? What next? Say again? What's next? Say again? Help me. Say again? Okay. I was wondering if someone was going to say that. That would tell me how many negative real roots we may have. Are we interested in candles with negative? No, we're not. We know there's one. There's got to be one positive real root. That's all we need to know. Okay? From Descartes' rule of signs. In a regular problem, yeah, you need to know the number of negative roots. But guess what? We're not interested. This is a real candle. Okay? It doesn't have any negative signs. Okay? So therefore, we're going to look for that one. So we got that done. What do we do next? The what? Okay, y'all like to jump right there, don't you? Okay? What do you use in synthetic division? How do you know what things to put outside the... Say again? Help me, somebody. Yes, let's do the rational zeros test. And what is that? All the rational zeros will be of the form P over Q, where P is all the possible factors of 75. And what would that? And guess what? We're only looking for positive roots. We're not going to mess with the negatives even. That would be 1, 3, 5. Will 5 go into 75? Next. Three times what? 75. 25 and 75. I think that's all, isn't it? Okay. Believe that's it. Over, and what's in the denominator? Your Q? 1. So, we don't need to go anywhere else. It's either going to be 1, 3, 5, 25, or 75. So now, that's where we go with synthetic division. You want to do synthetic division with 1? I'd rather not, because you can just plug 1 in, and what would you get? Negative 76. Is that a 0? Nowhere close. So 1, not going to mess with that. So let's move on to synthetic division using 3. 1's out. What's with 3? 3's on the outside. What's on the inside? 1, negative 2, 0. Then negative 75. Okay. I hate to lose my pretty drawing. Oh, that's going to be terrible, won't it? But I guess we have to. Can y'all live without it? That was too quick. Okay. Okay. Let's do the synthetic division. What do we do next? Say again. Skip a line, draw a line. Bring down the 1. Say again. Isn't that 3? Next. Next. 1, 3, 3. Is that going to come close to 75? No way in the world. Okay. So 3's not going to work. Ooh, yuck. Okay. 3's not going to work. What might you try next? 5. Let's try 5 next. Okay. What do you get here? 5. 3, 15, 15, 75. Bingo. I mean, no, you can't say that in Alabama, can you? Okay. Okay, ding, 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 ding. We got a winner. Okay. So we know that the side S is going to be 5. What would be the height? Second. S minus 2. So 5 minus 2 would be 3. That's going to be the height of the candle. So the product of the base squared, which would be 25 times 3, would be 75, and a third of that would be 25. Yes, that works perfectly. The volume of the pyramidal candle would be correct. Okay? So find the dimensions. What should be the dimensions of the candle? 5 inches on the side, 3 inches high. Sort of a squatty little candle, but it would work. Okay. By the way, they show some little candles there. You see them? Some of them are cones. The 2 blue ones out front are these pyramidal candles. Okay, good deal. Let's see how they did it. Y'all got your answers? Any questions on that? Solution, the volume of the pyramidal candle is 1/3 base times the height, where capital B is the area of the base. H is the height. The area of the base is x squared. They chose x. And the height is x minus 2. They sort of did some cheating there. I mean, they should have drawn a picture and that kind of stuff. Okay? So for the volume of the pyramidal candle, it would be 1/3 x squared times x minus 2. Substituting 25 for the volume, that's how much wax you had. 25 is equal 1/3 x squared times x minus 2. That would be 75 equal x cubed times x, 2x squared, multiplying through there. Subtracting 75 from 75 from both sides, you have your generic form, general form of your quadratic equation. You want to solve that. It's a cubic. So where do we go? The possible rational solutions, they went to that. They sillily chose negatives there. Not going to have any negatives. Oh, I missed one, didn't I? I forgot 5 and 15. I forgot the 15 in there. We didn't need it, but anyway. No, maybe we got it. I don't remember. But anyway, those are your possible x's because your constant, your leading coefficient was 1, so that didn't change anything. But you don't need any of the minuses because your dimensions are got to be positive. Use synthetic division to test some of the possible solutions. So how did they do that? Note that in this case it makes sense to test only positive x values. Now they said it. They could have said it earlier. All right, 1 you could just plug in and see it won't work. They went straight to 5 because they knew that would work. Shame on them. Okay, and that would give them, just like we found, bring down the 1, skip 1, draw 1, bring down the 1. 5 times 1 is 5. Negative 2 plus 5 is 3. 5 times 3 is 15. 0 plus 15 is, and they remembered to put their 0 in, didn't they? Okay. 5 times 15 is 75, and that adds a 0. That means 5 is the solution for the length of the side. That means the height would be 3. Okay. Now, there's a checkpoint here. Well worth your effort to do the checkpoint. Now, before concluding this section, here is an additional hint that can help you find the real zeros of a polynomial. When the terms of f of x have a common monomial factor, oh, and by the way, I forgot this. Can we go back to this one? I thought that Tyler was so close to skipping all this mess. I was ready to slap him, when he said factor. I said, well, how would you factor? Never came up with an answer for me. Factoring would have worked, and it would have been a far easier way, but this was instructive, and he did it because he likes to be instructive, okay? But if you had started this problem here, clever you, wasn't it? Okay. Let's go back, and without doing anything else we did, I thought he nailed it. I thought, oh my goodness, first person ever to come up with this is this one. I kept saying, how would you factor that? How do you factor a 4-term polynomial? How soon we forget. Factor by, whoops, grouping. Not groping, okay. In the first term there, what do you see? Common factor? 2x squared times 3x minus 2 plus 1 times 3x minus 2. Why? So I can have something to put with the 2x squared. Right? I mean, is it 1 times that? That? Okay, because I want to factor this out and leave something here as the other factor. Otherwise, you'll think it's a 0, wouldn't you? If I didn't write the 1 there and said factor out, what's the common factor? You said 3x plus 2.
I would just leave nothing there. Would it change the answer?
No.
Okay. I was just wondering. I didn't know if it changed.
Okay, right. Okay. Well, let's do it without it there. And I'll ask you, all right, is there a common factor there between these two terms? Yes, what is it? 3x minus 2. What's left? 2x squared. You leave it like that? That's why I put the 1 in there. Plus 1. If you factor that out, you have a 1 left. I thought if I write it there, it'll be more obvious that it's a factor. And guess what we had before? We had what we just give you as a 0, the first one. You'd say 3x minus 2 equals 0. Add 2 to both sides, and that gives you 3x equal 2. Divide by 3, and you get x equal 2/3. That's exactly what we got as our solution before, right? And the other factor you had was this one. It doesn't factor any further. Okay? So, you were that close. You just said factor by grouping, but I still would have come back and done the whole problem that way. But always check to see if you can factor. I thought, okay. Now, I just remember, I meant to say that earlier. Okay. Now, there's an example 11 in my slide set that's not in the book. This is from the old one. But what I was going to say, before concluding this section, here's an additional hint that can help you find the real zeros of a polynomial. When the terms of f of x have a common monomial factor, it should be factored out before applying the test in this section, okay? So, for instance, if our problem was f of x equal x to the 4th minus 5x squared, or 5x cubed, plus 3x squared plus x, okay? Where would you begin that one? Factor! All right, good. And what would you factor? Say again? I couldn't hear. X. The only common factor is x. And what do you have left? X cubed. Got the 1 there, didn't you? Okay. Now, you already know x equals 0 is a 0 because that's a factor. This one you can't factor by grouping, but you could look. So then you proceed with the rest of it. The only, okay, first, how many positive real zeros would you have? Three? One? Two? Is this one? No. Two? Not two. Two or zero. Remember, you always subtract two from it. Two or zero. So if you find one positive real zero, keep looking. There's another one. If you don't find any, it's fine, because there may be no real zero. How many negative real zeros do you have? That would become a minus. Stays a minus. Becomes a minus. And that's a plus. So you have one negative real zero. Okay? So you already have some good information. What are your rational zeros that you might have? This is pretty easy. Second? Plus or minus 1. Because it's 1 over 1. 1 from here and 1 from here. 1 over 1 plus or minus 1. So I know where, okay, I'll know how to begin to see if 1 is a real zero. Just plug it in. This would be plug in a 1. 1, negative 5. 1 minus 5 is minus 4 plus 3 is minus 1 plus 4. Yes, 1's a 0. Okay, if 1's a 0, that's a positive 0, you got to have another one. And I bet you it's another 1. Okay? Because that's the only possibility we have. Okay? So you do your synthetic division and keep going from there. Then you'll probably wind up with a negative real 0. Okay? So you would find it. Then you'd have 4 zeros, 0, 1, 1, and whatever your negative is. Does that make sense? So you see, use as much information as you can. They didn't carry it any further, so I'm not going to do it. Okay? Now, do you want to do example 11 even though it's not in your book? Oh, wait, no, I'm sorry. The other two, I'm sorry. Okay. Going back to the previous problem, 1 plus 3, x squared plus 3x plus 15. It says the other two solutions are imaginary. Yes. Okay. Are imaginary. I don't know if you see that just looking at it, but who cares? We found the one and only one real positive solution, and we don't care about any negative solutions or imaginary solutions or anything else. We found the one, so we didn't even look at that. So that's just the end of example 11. Sorry. Forgot about that. Any questions on that? Okay. You can conclude, let me erase the writing here, that the base of the triangle mold should be 5 inches by 5 inches. The height should be 5 minus 2, which is 3 inches. We already concluded that. For instance, by writing, oh wait. All right. This is what I was just saying. I'm sorry, I didn't know they had it on the slide. I thought it was going to something else. X equals 0, we did all this. And the remaining zeros can be obtained by analyzing the cubic factor. We already analyzed it, saw there was either 2 or no positive real solutions, 1 negative real solution. We tested it, found out 1 would be a positive real solution. It makes 1 the only possibility for the second real solution. Okay? No, not necessarily. I'm sorry. You could have a positive irrational solution. Okay? So yeah. So it didn't have to be 1. Okay? But they didn't do any further either. Now, if you want to take it further, we can. We can go and analyze it all the way. You want to? Yay or nay? Yay? Okay. Nay. Okay. I thought you looked like a nay, but I thought you said yay. Okay. All right. You could analyze it further. Okay. Let's do the vocabulary. Top of page 164. The blank blank of blank states that if f of x is a polynomial of degree n greater than 0, then f has at least one 0 in the complex number system. Okay, first thing we did in this section. Very first thing we did in the section. Page 154. Title is the first subtopic. Title is the first block they do. The fundamental theorem of algebra, exactly. Number 2, the blank 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 states that if f of x is a polynomial of degree n greater than 0, then f of x has precisely n linear factors. F of x equals some constant a times x minus c1 times x minus c2 times up to x minus cn, where c1, c2, up to cn are all complex numbers. The what? Linear factorization theorem. That was the second thing on that page. Okay, number 3. The test that gives the list of the possible rational zeros of a polynomial function is the blank blank test. Rational zeros test. They sort of gave that one away, wasn't it? Number 4. If a plus bi is a complex zero of a polynomial with real coefficients, then so is its blank a minus bi. What do we call a minus bi to a plus bi? Called the, actually I usually use two words here, complex blank. Okay. That would be on page 158. Say? Okay, the conjugate. Okay, the conjugate. That I call it the complex conjugate. Okay. Number 5. Every polynomial of degree n greater than 0 with real coefficients can be written as the product of blank and blank factors with real coefficients, where the blank factors have no real zeros. Any ideas on that one? About page 159. Little block on that page. Y'all are into it this morning, aren't you? Veterans Day was really rough, okay? Page 159. Linear, quadratic, and the third blank is? Is what? No, it's one of the other two. Quadratic, where the quadratic factors have no real zeros. Feel like a dentist, okay, pulling teeth. Okay. A quadratic factor that cannot be factored further as the product of linear factors containing real numbers is said to be blank over the blanks. Okay. Go back to 159, exactly under the block you just looked at. Second? Irreducible over the reals. Okay. Thanks for the help. Okay. Now, number 7. The theorem that can be used to determine the possible number of positive real zeros and negative real zeros of a function is called the blank blank of blank. sort of like that, the first word. What was the guy's name? Descartes. What's the second blank? Rule of. How many times have I said it this morning? Go to page 161. The Descartes rules of sign. Whew. Okay. Number A. A number B is a blank bound for real zeros when f of f when no real zeros are less than b, and is a blank bound when no real zeros are greater than b. Second? Which one? No. When no real zeros are less than b, that would be a lower bound, and the second one is upper bound. Whew. We love those vocabulary, don't we? Okay. Homework exercises here. Any of the odds 9 through 13. Do either 15 or 17 or both. Any of the odds 19 to 27. Either 29 or 31 or both. Either 33 or 35 or both. 37 or 39 or both. 41 or 43 or both. Any of the odds 45 to 49. Actually, you don't have to mess with those because those are all have complex parts in them. You can play with them if you want to, but okay. Actually, it wouldn't be a bad exercise. Then either 51 or 53 or both. Any of the odds 55 to 61. Any of the odds 63 to 79. Any of the odds 81 to 85. Any of the odds 87 to 93 using what? 87 to 93? You closed it already. Descartes' rule of signs. I want you to say it one more time, okay? Any of the either 95 or 97 or both. Either 99 or 101 or both. 103 or 105 or both. And then either 107 or 109 or both. And then do either 111 or 113. Good little think about it there on 117 to 121. And maybe even 125. You don't have to do those. Those are just a little bit more to work on. All right. Any questions? 2.5. Okay. I needed to get out of this. All right. We've still got 2 minutes. Okay. So let's at least introduce 2.6. Well, it may take 2 minutes for it to open. Ah, here it comes. What's that? Okay, 1 minute. Okay, let's see if it's going to get open in a minute. Okay. All right. Now, it's continuing in polynomial rational functions. What we're dealing with now is the rational function part. What do we mean by rational functions? Any ideas? What does the term rational mean? Ratio, which means division.
I don't like division.
Yes, we do. Okay. And what are we dividing from rational functions?
I quit.
2 polynomial functions. One polynomial function divided by another. That's where we'll begin next time in the objectives here on page 168, 2.6. Yes, sir.
So, it's doing with something on the quiz. I was trying to go through here and figure this stuff out.
Okay.
All right, so when I have this, I know these are my x's here. These will be the x's. Since I factored out, this will be a negative 1, negative 7. Will this be a 1 or a 0?
No, zeros. Because what? How did you get this to be a negative 1? So x plus 1 is equal to 0.
Okay.
Subtract 1. So you say x, is that to the second
Square,
power?
yes.
Okay. X squared is equal to 0. What could x be?
0.
0 or 0. So multiplicity of 2.
Okay.
So double 0. Double 0.
Okay, so that's multiplicity. So that would be multiplicity of
One,
One.
and one, and two.
okay. Okay.
Did I just answer the question on the quiz?
Well, I was.
Yeah.
I
Okay.
didn't know how to do. I looked everywhere to try to figure out the multiplicities under
Yeah.
stuff, and I could not find that anywhere on there. So
I've
like
noticed
I already had all this answered on
Uh-huh.
there.
Yeah.
I was just trying to figure out how to do the multiplicities
Yeah.
because I had no idea how to do it.
Okay. It seems like this class has trouble finding things in the book.
Okay. I mean, I looked through it and read, and I still couldn't find it. I went through every section, and I just missed it. Is all I did. Wow, I just missed it.
Okay. But when we go through those vocabularies, I mean, they're right there in the book. I shouldn't have been recording all that.